Hi, Mick McQuaid here to help you with Milestone 1. Milestone 1 says in the homework instructions file, which you need to go over carefully, by the way, it says that you're going to be doing tables and summary stats in this file. So it's a numerical description of the data in the vehicles.csv set. And one group member is going to post your output. So your output is going to consist of m1.qmd and m1.html for Milestone 1. And you're going to use the template.qmd file as a starter file. You're welcome to do it on your own if you prefer, but this will be, you'll find helpful. And you must keep the vehicles.csv file in the same directory as your QMD files. So I do not see any setwd functions in your output. Because I'm going to put all the students' files into one directory along with the vehicles.csv file for grading. So it's important that you use exactly the fread function that I've written in this template.qmd file, which we'll go over in a minute. Okay, so there are two files to download. You don't strictly need vehicles.dat because I've put the contents of that into the template.qmd file. So if you use the template.qmd file, vehicles.dat is optional. But vehicles.csv is not optional. That's a huge file. And it's a comma-separated values file. That's what CSV stands for, of cars advertised on Craigslist. And you're going to summarize the data using contingency tables, which we learned how to do, and summary statistics, which we learned how to do. And this will also prepare you for the other milestones because this is going to familiarize you with the data, and it's the same data that you're going to use for every milestone. Now, not all the columns are useful. For example, I think I've mentioned elsewhere that the VIN column is not useful unless if you're a car expert, there is information you can extract from the VIN number. But if you're not a car expert, just don't worry about that. URL is generally not an interesting column. Regional URL is not an interesting column. There are several. Lat long is not an interesting column unless you're a cartographer and you want to make some maps of the locations where these cars are being sold. You're welcome to do that if you want, but it's really beyond the scope of this class. So I would advise you to get rid of the lat long columns. And not every column is easy to describe, so we'll go over that also. So this assignment is about using your best judgment. That's really the thing I'm grading on is, did you use your best judgment? Most of this other stuff is going to be pretty easy because we've gone over it in the week 01, week 02, and week 03 files, which I'm also going to show you. Okay, so let's take a look at the template.qmd file. So this already has a name. You're going to put in your group members' names in the author location. You're going to replace these. And you're going to use this exact little chunk of code to read in the vehicles.csv file. And these are the names of the columns in this vehicles.csv file. And as I mentioned, there are several like lat long, image URL, region URL, and ID. All those are pretty much useless for this assignment. The most important one is price, and several of these others are very valuable from doing contingency tables, summary statistics. For example, you can find the average age of a car. And some of this data is numerical and some of it is categorical. So you're going to use different techniques for describing categorical data than you are for numerical data. So for instance, you can use contingency tables on columns like manufacturer, model, condition. You can use it on cylinders because there's a very small set of cylinder numbers. You can use it on fuel type. But odometer is the miles traveled by the vehicle. That's a numerical one. You're going to want to use summary statistics on that. Title status is another categorical one. another categorical one. I can't remember what this is. You're going to have to investigate it. In fact, let's just investigate and find out what size is. So I'm going to switch to a copy of R. Here is a copy of R. Let me just now notice it takes a long time to read in vehicles.csv. So my suggestion is that you save it as an R data file, which is much faster to load and which also will preserve some of the things that you do. But let's just take a look at that, let's say table BF size. Oh, okay, so that is a categorical variable, and you can see that there are 306,000 cars that for which the size is not listed in the Craigslist ad. What happens is a lot of people are impatient in filling out the Craigslist form, so they just throw everything into the description field instead of filling out the fields, checking the boxes in the Craigslist form. As a matter of fact, you might want to pretend you're listing a car to just see how the Craigslist thing works, and then you'll better understand how you end up with situations like this. Now, here's where when I say you should use your judgment, here's an interesting column, paint color. So in the past, I've had students do a contingency table of paint color and some of the states, like some northern states and some southern states, to see if, for example, white cars are more popular in the South and darker colored cars are more popular in the North. If I just do table DF paint color and DF state, there are a lot of entries in this table. It's hard to tell what's going on in this table. See how many entries there are? But if you were to just pick a few states, like pick a few southern states and a few northern states, and you might even want to pick a few colors, because obviously there are very few purple cars in the data set, very few orange cars in the data set, very few yellow cars in the data set. The majority are white, black, or blue, although you can see that some of these other ones have a lot of entries as well. So using your own judgment could be deciding what might be an interesting contingency table, for example, paint color and a few northern and southern states, or even categorize the states into northern and southern and just do a contingency table of that. Northern states is one row, southern states is one row, and then say the four most popular colors as columns. Okay, now this in the template file, there are these sections and subsections. So this first section is data description. That's milestones 1 and 2. Part 1 is numerical description. That's milestone 1. And part 2 is visual description. That's going to be milestone 2. And when you have completed these two milestones, you should have a really good description of the data set, and you should be in a much better position to do a regression analysis, where in the regression analysis, you're going to try to predict what factors influence the price of the car. Okay, so now I want to go back and look at the next most important file to look at, which is the week 03 file. So in the week 03 file, I talk a lot about milestone 1. So I describe the template file, and I give you an example here of things that you can do. So here's finding out the count of all the title statuses. And I think I mentioned in class that if you were to buy a car in real life, you would only want this category, clean. You want to avoid a rebuilt, salvage, lien. So these have meanings that are important to insurance companies. You can't, after you buy the car, you have to get insurance. You're required, I think, in all states to get insurance on the car. And reputable insurance companies won't insure a rebuilt or salvage title. And a lien on the car means that somebody else really owns the car, so you're not really buying the car, you're going to have to pay somebody else. And of course, missing title is problematic. And parts only, obviously, you're not going to buy a car for parts only unless you're a mechanic. Okay, so this is a good way to investigate categorical data, is to do counts of the columns that are categorical. You're going to have to figure out which columns are categorical. And you can do that in part by looking at this data dictionary. And then you're going to use different techniques for describing the numerical data than the categorical data. So here, for example, is one way to find summary statistics for the price of a car. And then, of course, you find out that one of the prices is $3.7 billion for a Toyota Tundra. So you now realize, after you've done this, that you're going to have to cut out some rows in the data set. You don't want any rows that have a price that's obviously ridiculous. And there are several that are listed at over $1 billion. So these statistics aren't that meaningful. The mean has been dragged way upward by these outrageous outliers. And so I give you an example here of how to get rid of all the cars that have a price of greater than $100,000. There are some that have legitimate prices greater than $100,000, some exotic cars. But for our purposes, if you do this, you'll still have over 300,000 automobiles to analyze. And this is a general way to reduce rows in a data set. So what I've done here, so the part before the comma is a row, the part after the comma is a column. So if I put an expression in this row part here, that expression will return only the rows of the data set that satisfy that expression. So we have our existing copy of DF, and then when this is applied, we get a new copy of DF, and the old one is destroyed. So if you mess up on this, you have to go back to an earlier stage. And that's all that these two paragraphs say, is this stuff about expression that you can put in the row part of the specification to reduce the number of rows. And one of the things that I tell you to do, I tell you to go through in this file, I tell you, this is just how I would do it. I would go through these 8 steps if I were doing this homework. Okay, and the first step is get rid of rows you don't want. The second step is to get rid of columns that you don't want. And for columns, we can use the select operator. I don't think maybe I've shown the select operator in here somewhere, but let me just show it to you. Oops, wrong window. Let's say that I want to say DF gets DF select. Oh, I didn't load the tidyverse yet. Let me load the tidyverse. You need to do that at the beginning. You're going to use select. Okay, and then we'll say DF. Oh, let me actually list the names of the columns here. Names DF. Okay, and so I'm going to get rid of a few columns. So I'm going to say select minus lat minus long minus minus ID minus URL, oops, minus region URL. Is there anything else here? Oh yeah, minus VIN. Now, how is the VIN represented here? I got to get this out of my way. I'm not seeing VIN here. Oh, VIN is capitalized. Okay. Okay, now if I say names.df, or names parenthesis df rather, I get the same output except that all these things that I said minus are missing. So that's a good way to get rid of columns that you don't want. So what I suggested next as a next step is to convert some of the character columns to factor. So if I say strdf, I find out that most of the columns are characters, and they should be factors for two reasons. One is it's faster and takes up less space on the computer to store things as factors than as characters. And the other is that there are some functions in R that are available for factors that are not available for characters. And we'll learn more about those later. So I give an example here of how to do that. So I can say df $state gets as factor df $state. So let me just do that here. Df $state gets as factor df $state. Now, if I run this, did I put enough parentheses? Yeah. So notice that state here is a character variable. If I do this, and then I do that same command again, oops. Now state is a factor with 51 levels, because I think DC is a factor, is one of the levels. So now I can do factor functions on that. So that's step 3, in my opinion. Step 4 is save your file by saying something like this. Should it be a capital D or a small d? I can't remember. Capital D. Okay, so it's going to save this file in a compressed format. So if I now try to load this file, so after I do this, I maybe stop and go and have a cup of coffee or whatever it is I do and turn off my computer. And then when I turn my computer back on, I'm going to load this file instead of f-reading the vehicles.csv so see how fast that was compared to the 2 minutes or whatever it took to f-read the vehicles.csv file. So for your intermediate work, intermediate sessions working on this homework, hopefully you're not trying to do this all in one mega session at the last minute. Hopefully you work on it for a while and then you stop and do something else and come back to it. So each time you can use this file to save time. I mean, use this function to save time. So that's what all this is about. Now I'm going to suggest that you open a file called intermediate.qmd and that you do all your work in that file, or most of your work in that file, because you're working as a team. And so you have individual team members working at the same time on different variables. So my strongest suggestion is that you pick a few variables for each team member to work on. So each team member is working on 4 or 5 variables, 4 or 5 of the 4 or 5 of these columns. So after you delete a few, you'll probably have about 20 columns left, 4 or 5 team members. So you're going to pick 4 or 5 columns per team member to work on. And then you're going to put all of your work in there at the beginning of that file. You're going to load this and then do your 4 or 5 variables. And then step 7 is to paste your work back into the template.qmd file so you can run it as required. Remember, you are not turning in an RData file in this class. Your m1.qmd file must start with reading in the vehicles.csv file and do processing on the resulting data frame. Okay, so this is just to save you time at an intermediate level. I will take off massive points if you include the RData thing in what you turn in. And then you're going to merge your template.qmd file. Maybe you name it with your initials or something like that, and you merge it with your group members into one m1.qmd file. So yeah, it just says here that it's obvious to divide your work by different columns assigned to different group members. And I gave you the option of using a stem and leaf plot here. You can either regard stem and leaf plot as numeric, in which case you can use it on the numeric variables in the data set in Milestone 1, or you can regard this as visual, in which case you could do one in Milestone 2. Now, you should also be looking at these previous files, the week 02 and week 01, because we talk about some things that you can do. We talk about some things that are for Milestone 2, but we talk about some things that are for Milestone 1 in these files. Okay, so all these things that I'm highlighting are things that you can do in Milestone 1. And you can always use the table of contents in this file to get to stuff like this. So here's a way of finding out the mean of a particular column. Here's a way to get a summary of a particular column. There are a number of ways that you can get statistics on multiple columns. So for example, the call means function will give you the means of all the columns. And by default, it does it in this really annoying way that I can't stand. So I do it like this. This second one here is what I would do. That gives you the column means in decimal notation. And while you're exploring, you're not going to turn in any graphics, but while you're exploring, you might want to do graphics, for example, to find outliers. So in your exercises, I asked you to do some statistics on what is this? The Lone 50 data set. I asked you to do some statistics on this, and I asked you about why the mean is so different from the median. And if you did a box plot, you would know that there are these 4 outliers, and you would know to get rid of, say, incomes greater than 150,000, because they're outliers in this data set. This is an old data set. Okay, so mean of X, and they obviously didn't live in Austin if their median income is this low. So here are, these are not critical for this milestone. I'm just skipping over all these. Now this is really valuable. This whole part here, categorical data, is really valuable. You're not going to do a mosaic plot, but you will do tables. So that's how you create a contingency table. And here are some more statistical summary tools. So you can get the range of a numerical variable with this. And you can create a table of a bunch of variables with their ranges like this. And you can substitute, where it says range here, you can substitute mean or median or whatever statistic you want. Here, I would like a variety of statistics, standard deviation I also want. And this actually is even more cool because this is a compact way to show a lot of information. but it's, you know, it's obviously painful to write out. So you're going to want to copy and paste this. I think you can copy and paste it right there. And then you're going to substitute DF for auto, all these others, and you're going to substitute the column numbers or the column names that you want to use in place of these. Everything else can be this pretty much the same, except you might want to change the statistics that you're using. I like mean, standard deviation, and range for a lot of things, but it doesn't work for something like price if you don't take out the outliers. And here's, again, a way to remove rows. So we just arbitrarily removed the 10 through 85th rows in this data set, but you can see here that we used row numbers to remove them instead of statistics about the rows. And we did a bunch of exercises that you can also use. Some of these exercises, people did cool things like this, and you can use these in your statistics also. So anyway, that's about it. So if you have questions, ask me by email, and I will try to email the whole class, because usually the questions that you have are going to be questions that more than one person has. So, so thank you for your attention, and be sure to email me with more questions.